Welcome back. Here's a couple more examples on rationalizing the denominator. So here's the previous slide that I put up from the last video, rationalizing and how to actually get rid of that radical in the denominator. I want you to look over it. Again, same index, same radicand. It's just that the exponents for the radicand need to add up to the index. What's left is just your base of your exponents. So let's do an example. So first thing, I realize I'm going to simplify first. Okay, this one might be a little tricky for those of you who are following along. So let's do it first. So I have 12 over 10, which reduces to 6/5. So I now have 6/5. I have a to the first minus 3 is a squared. B to the third minus b to the first will give us b squared and c. So this is all raised to the third power. So I simplified first. Again, when you're dividing, subtract your exponents. If your exponent answer is going to be, after you subtract and you get a positive number, goes in the numerator. If it's negative, goes in the denominator. So I know a squared is in the denominator. So now what am I going to multiply by? Okay. Noticing that my index is 3, my exponents are less than my index, so I have to multiply by, okay, same radicand, 5a, but my exponents have to match up. So this is going to be 5 squared, a to the first. This is, again, going to multiply what I multiply by the denominator. I also have to multiply to the numerator. So what am I left with? It's going to be just the base of my exponents, 5a. And then now I'm left with, up in my numerator, 6 times 5 squared, a, b squared, c. So I'm going to now simplify 6 times 5 squared. So 6 times 25, which is going to be 150. So now I have the third root of 150. A, b squared, c, all over 5a. What's the highest perfect cube that goes into 150? So 150, the highest perfect cube. The highest perfect cube that goes into 150 is just 1. So there's our final answer. For those of you that want to know why is there no perfect cubes in 150, so let's break down 150, which is 15 times 10, which is 3 times 5, which is 5 times 2. As you can see, there are no groups of 3 of the same prime number. We'll do the prime factorization tree. So there's our final answer. Let's do one more example. Rationalize, so I'm going to simplify first. So I'm going to write it as the square root as 3xy squared over 5xy to the third, which is going to be the square root of 3 all over the square root of 5. 1 minus 1 is 0. Anything to the 0 power is 1. 2 minus 3 is negative 1, so I have a y in the denominator. Let's get rid of this extended line in the radical. So what am I going to multiply by? You should know that I'm multiplying by, since nothing is in the index, it's 2. So I'm multiplying by the square root of 5y. So I'm multiplying by the square root of 5y. So now I have the square root of 3 times 5y all over 5y. Because when you rationalize the denominator, your denominator is just the base of your exponents, or it's just your radicand without exponents, equals the square root of 15y over 5y. And you can't reduce this because, again, 15 is divided by 5 is 3, but square root 15 divided by 5 is not 3. So again, square root 15 divided by 3 does not equal, 5 does not equal 3. So there's your final answer. So I hope these videos helped you with rationalizing denominators. If you have any questions, email me, see me before school or after school.